So my name is Rich Saintamore. I'm president of Marathon Pipeline, and I've been with Marathon for almost 30 years, and most recently in this role for about 3 years. And so the goal here today, and I was talking with Bill last year at this meeting about an opportunity just to educate folks about pipelines and what's going on. And I saw by the show of hands that we had some folks with knowledge and others, many, without any base knowledge. And so we'll hopefully expand upon that during our time here today. What I would ask, in light of what Virginia mentioned, is we'll save our time for questions at the end. And we also have a Q&A session, if you saw later on, that we'll be able to get questions answered as well. And so hopefully we'll have some time here at the end of our dialogue to take any questions that you might have. So when we look at our pipelines here, make sure I can move the screen's moving forward. Just a little bit of background, right? When we think about this. In fact, I had put this together earlier in the year, and I was just checking some of the stats to see if anything changed. And lo and behold, this is taken right from the National Pipeline Mapping System, and this number actually flipped to 3.3. So there's some rounding in there, right? But just to put perspective on it, so around 3 million miles are set in the natural gas space, and around 200,000 miles, 250,000 miles or so are in the liquids pipeline space. And so for our time today, I'm going to be focusing mainly on the liquids, but I did just want to show you what the universe looks like out there in terms of pipelines. And again, this is a resource down below there. If you type in on your favorite search engine, National Pipeline Mapping System, you'll be able to dig into detail in any one of those systems. All right, so I mentioned the liquid side of the house that we'll be talking about in more details. So let's talk about what we mean when we say liquids being transported in pipelines. And so for our discussion, we'll first touch on crude oil. And there are many types of crude oils that exist, mainly dependent upon where they're derived from the ground. And their properties can change. Some can be very light in nature. Some can be heavy. Some can pump easily, or a term known as viscosity. So they might have a low viscosity, and others might have a high viscosity, meaning they don't pump as easily. But those crude oils all flow in that same crude oil pipeline. The next thing we'll talk about is refined products. Those might be something that you're more familiar with. That could be the gasoline that propels an automobile down the road. That could be the jet fuel that provides energy for the travel that you took here by plane, right? Others include diesel fuel, kerosene for maybe home heating, or other home heating fuels as well. Lesser commodities, and I say lesser meaning that a much smaller volume of commodities that are transported by pipeline, include carbon dioxide and ethanol. And we'll look at that here in just a little bit. So these are some by the numbers, if you will, about the volumes that are transported. So here we've got, I'll start on this far right here, over 22 billion barrels of products are delivered every year. And when I say a barrel, just to get us all level set, there's different measurements of barrels depending upon the industry that you're in. But in the oil and gas industry, a barrel is equal to 42 gallons. So if you ever hear that term on the news, you'll hear 42 gallons equals 1 barrel. So sometimes different agencies will report volumes in different units. And just to get everyone level set, that's a good one for you to have in the back of your mind. And so this just talks about the mileage here in terms of different types of product pipelines and crude pipelines and CO2 pipelines. So you'll see like ethanol, there's not a lot of ethanol pipelines, 22 miles worth, right? CO2, a little over 5,000 miles, much smaller. Then when we get into crude oil pipelines, we're at 84,000 miles. And then this mentions highly volatile liquids or HVLs. That's like propane and butane. So if you have a grill at home, perhaps it runs on propane. Butane is another industrial fuel source that's used, and it can also be used along with other HVLs like ethane in the manufacture of products. And ethane is something that's used to make different types of plastics that have a wide range of uses. So again, a little bit of background on the miles of pipes and how much is delivered in total when we look at all of those. And I will mention, and you can see it on the slide there, about the breakdown. You see around a little over, right around 2/3 or so of it is broken down by crude, and the rest is in these other products that you see here on the screen. All right, so I'm going to watch a little video here, and this just talks about the movement of material from one location to the other, and just again to help level set up.
Pipelines deliver transportation and home heating fuels from refineries to your local region. A tanker truck will make local deliveries to your neighborhood gas station or home. Pipelines deliver jet fuel straight to airports. So, the next time you head out, by car, truck, or plane, remember, pipelines help you get where you need to go.
All right, a very simplistic video, but just highlighting the direction and the uses that we see here. So a little bit more background here on how fuel might get to the public. And we talked about crude oils having different types of properties. And again, it really comes on where it's I'll say, produced from the earth. And there's domestic production, and that is collected locally in small gathering systems. Then those gathering systems are brought to main trunk line pipelines, and then they are eventually brought into a refinery. Those same main trunk lines can also have crude oil that's brought in from other sources. And I show here via tanker, but it could be railed into a larger community. It could also be brought in by truck as well, but also large crude carrying vessels are a primary mechanism for getting foreign source crude oil into the country. And then again, from there, it jumps onto those main trunk line systems and gets into a refinery. At that point, the refinery then changes the molecular structure of that crude oil and eventually gives us those refined products that I mentioned earlier. That's your gasolines, your jet fuel, your diesel fuel, your kerosenes. And then eventually we'll also get with that some of those LPGs or HVLs that I mentioned as well, propane, butane. And those will have outbound pipeline logistics, right? They may be stored in a tank and then eventually pumped to another location for final sale. So that sale may then occur at any given location across the country, and again, stored in tanks, usually placed on a tanker truck and then brought to its final destination. In this case, it's a retail gas station, but again, it may be home heating that's utilized in your house. Depending upon where you're at in the country, that's a pretty prolific source of energy, especially used during the winter time. All right, so just a quick aside, I often get this question a lot, and this is just about, well, how does the product move in the pipeline? So there's always liquid in the pipeline at all times, and the liquid touches one another. And the question is, well, do you need a separate pipeline to ship gasoline and a separate pipeline to ship diesel fuel and another pipeline to ship jet fuel? And the short answer is, no, you don't. You can, for sure, but that's often less efficient. And so what we do is have the opportunity then to what we call batch different types of pipeline materials, and they come in contact with one another. And you're like, well, don't they mix a lot when they touch one another? And the answer is no, they really don't. As long as the pipeline moves, they mix very little. Now there is some, and you'll see here, maybe we have premium gasoline to regular gasoline. And so if we have to, say, cut one into a different tank, where we store them, we'll actually put the premium gasoline into the regular gasoline. And so you get a little bit of a bump, if you will, in that. So whatever little interface that occurs. Other interfaces are more complicated, and by that meaning the products maybe aren't as compatible. So in this example here, we might have regular gasoline going into home heating oil. We don't want those two products to mix because the gasoline in a home heating application is not safe. And so what we do is we cut all of that material into a separate tank. And that material, once it's been commingled and touching one another, is called transmix. So if you ever hear that in the news, transmix is just a compilation of different products commingled together. And so we'll take those products and we put them into a separate containment vessel, a separate tank, and then ultimately those are typically sent on for reprocessing back into a constituent component, back into regular gasoline, or back into jet fuel, or back into diesel fuel. And so the goal there is to make sure that we have the exact product that customers want and need for both efficiency and, most importantly, for safety. So a little bit about how these things all move in the pipeline. And so again, they'll touch one another. Crude oil is very similar, even though we might have different types of crude oil. They'll all run in that same crude oil pipeline. And again, they'll just touch one another. And if we need to, we'll cut some of that crude oil out into different materials as needed in a similar example here. One thing I will say, you can run crude oil and products together, but it's not done often. So oftentimes crude oil pipelines run crude, and products pipelines run products. Again, all kinds of products in that one pipeline, but we don't always, and I'll say rarely, do we mix the crude pipelines and the refined products together in the same system. All right, we'll keep things moving here. So we're going to talk a little bit about what I like to call the three-legged stool concept. And maybe you've seen this analogy used before, but I think it's very appropriate when we look at pipeline safety and how pipelines should operate safely going forward. And so as we look at the legs of the stool, we have the regulators, and we'll touch on that here a little bit. And then we have the public, which is all of you here and many more. And then we have industry. That's the operators that operate and own these assets. And working together collectively, transparently, and understanding our goal of being safe is important. And with those basic understandings, we have the opportunity to help improve pipeline safety. So let's touch on this in a little more detail. So on the regulator side, and we'll have folks coming in on the regulator side here a little bit later on to share more detail. In fact, Clayton used to work for one of the regulators. I just found that out here just a short while ago during our little meet and greet. But these are all the different types of regulatory agencies that are involved. There are some that are very well known that you all are familiar with. That might be PHMSA here, the Pipeline and Hazardous Safety Material Safety Administration. But there might be others that you have less knowledge of. For example, the Coast Guard. They can help regulate how pipelines get their material into the system. So I mentioned those ocean-going vessels as an example. Well, the Coast Guard has some say into how material is offloaded and brought into pipelines, as an example. Another one here that maybe you're less familiar with is the TSA. You thought, well, gosh, I thought they just helped us out in airports. In reality, the TSA is also responsible for all the cybersecurity as it relates to pipelines. And we'll touch more on cybersecurity later on in our talk here. But again, different levels of responsibilities that not everybody is familiar with. The EPA also has a say in pipeline regulations as it relates to water, as it relates to the air. And again, you can see as we move on here, this works its way all the way to state agencies as well as local municipalities will also have different oversight elements when it comes to pipelines. So I'll mention here, I just saw this, we had a little, I think a font issue and where it says after hour, it's supposed to be our daily lives. And so this is right here from, taken right from PHMSA's website here, and it talks about their mission is to protect people, the environment, by advancing the safe transportation of energy and other hazardous materials that are essential for our daily lives. To do this, the agency establishes national policy, sets and enforces standards, educates and conducts research to prevent incidents. We also prepare the public and first responders to reduce consequences if an incident does occur. And so this just talks a little bit on their breakdown of how PHMSA is structured. There's 5 regions that are geographically placed throughout the country, and then those regions actually will take an operator and oversee an entire element of that operator's performance. And so I think there'll be some folks talking more on PHMSA here later on today, but I did just want to provide a quick highlight as they are our primary safety regulator in the pipeline space. Okay, so moving on here, one of the ways that we look at pipeline safety, and this is coming more from the operator side, but it's important for, I think, for, I'll say, all of our regulators and for the stakeholders at large. And I'm going to switch our dialogue here back now away from the regulator side on our 3-legged stool. And come on in, grab a seat anywhere. Hello. And so we're going to switch our another leg is back to the operator. And so one of the ways that we look at this is, as an industry, we look to set goals to help improve our performance. We realize safety needs to happen with all of us, not just one operator, but as the industry. And so we collaborate through industry trade organizations. One of them is the American Petroleum Institute, or API. Another is the Liquid Energy Pipeline Association, or LIPA. And we collaborate together with those agencies, or those organizations rather, and try to put together items that we think will help improve pipeline safety across the board. And so we put together our strategic goals, and you can go out to API's website, again, or use your favorite search engine and type in, API pipeline safety commitments or strategic goals, and you will be able to pull all this up and see this information. And I encourage anyone to do so if they haven't had the opportunity to do that. And we'll touch on some of those things here in a bit more detail. One of the hallmarks as it relates to improving pipeline safety is around pipeline safety management systems. And for those that aren't familiar with management systems, I want to take just a brief moment to describe what that means, that term. So again, pipeline SMS, or safety management systems, is really a mechanism and a mindset by how which we approach every aspect of our work. And we approach it with this mindset. And you can see it in the background here. Plan, do, check, adjust, or act. And those 4 words really help define who we aspire to be. And I say that because first we have to plan on how we can get better. And then we implement those plans. That's the do. And then we need to see, did we get the results that we were anticipating? Did we get better? And if so, yes, what do we need to do to keep improving? If it didn't work out the way we anticipated, what do we need to change so that we can do better? That change is the adjust. What do we need to adjust so that we can be a better performer, that we can have safer pipeline outcomes? And so that's plan, do, check, adjust is embedded in all of the work processes that we undertake. And we want that to go down to every level of employee that works in our organizations. And so this has been continually being adopted across the industry, and we think this is the pathway to help improve pipeline safety. I say all this to say this is a journey, and we are nowhere complete on it. And I say that with the deepest level of humility. We are not perfect. We have opportunities to improve. And we need to look at each of those opportunities and grab a hold of it and analyze it and study it so that we can do things better. And so let's touch on that here in a little bit. We look at the performance, we look at the safety culture, and we think together when we look at our pipeline safety management system that we really can achieve zero incidents. As I stated earlier, we have a long way to go before we're there. So some of these areas that I want to focus on specifically for the operator now. Committed to environmental stewardship. There's a lot of ways that companies are adjusting their work practices to help be better environmental partners. First, I'll talk about like rights of way. We're looking at using different means and partnering with local communities to say, hey, if we're changing our landscapes, one of the ways we're looking at is putting in native and plants and species that are local to that area. And by doing that, we create habitats that are helpful for different types of species. An example is the monarch butterfly, right? And before I took this role, I didn't realize how their habitat had been being eroded over time. And through this, I'll say, focused effort, we can transform our right-of-ways to be an improved habitat for the monarch butterfly. We can also work with our stakeholders along those rights-of-way, and we say, hey, are there specific animals that you would want to attract in this area? Maybe we have people that love deer and in the Midwest or in the Southeast, and they say, it would be awesome if I could have some type of plant structure that would attract deer because I'd love to observe them. And we can work with them as we look to convert our rights-of-way to more of this sustainable mindset. And so this is a partnership that we can collaborate on with many in our communities and that they can see the benefits. Water conservation, and you're like, gosh, how can pipelines help conserve water? Well, we can advance our technologies in how we inspect our pipelines. One of the ways that we help ensure pipeline integrity is to perform what we call a hydrotest. A hydrotest is filling the pipeline with water and then putting a pressure on the pipeline, and then we have to then treat the water once we're done. And so that takes energy, and we can't just dispose of it by natural discharge. And so one of the ways that we're able to do that is advanced technologies through inline inspection tools, and I'll touch on those in a little bit longer, or a little bit later on. But those technologies allow us to inspect the pipeline from the inside and give us greater insight than what a hydrotest alone can provide. So we'll still do hydrotests, but we'll do fewer of them by using newer technologies to help us ensure pipeline safety. Another one is to incentivize behavior of pipeline operators. So there are awards given out within the industry for how we perform as it relates to pipeline safety. So continuing to provide an incentive for operators to be recognized for their performance in doing better in this space. And then the last thing is, again, continuing to advance technologies through advanced concepts. And so it's looking at different types of AI, and I'll touch on this here in a bit as well, to help advance our ability to detect threats to the pipelines in a much higher level of accuracy than we've ever been able to do before, as well as if there is something that's going on adverse, that we can detect it quicker than we have been before. And I'll build some of these technologies out here in just a bit. So some of the regulatory drivers on emergency preparedness. I wanted to touch on this. This was, I think in our survey, Virginia, this was a topic that had garnered a lot of discussion, or at least some thought on it. And so I wanted to touch on this ahead of time. So as a pipeline operator, there were some requirements set forth, and originally started with the Clean Water Act of 1972, and that propagated on to the Oil Pollution Act of 1990. And then there's also the National Preparedness Response Exercise Program that kind of drives a lot of our emergency response preparedness. And so that starts with training, right? First and foremost, it starts with training. And if you go back to that strategic plan that I mentioned that we have with API, one of the things that we're committed to doing is improving the capabilities of both companies or within the industry, as well as our first responders. So one of the things that we've done, we knew that some first responders had less experience with responding to certain materials, like CO2 as an example. So there's a free online training for first responders that we developed that is able then to be utilized at their convenience to help train them if they have concerns about CO2. One of the things that we see is that many of our small fire departments, they do admirable work. But what they typically see on a day-to-day basis is a house fire, right? They respond to small dwelling fires. They don't respond to something that might involve a hydrocarbon, as an example. And so one of the partnerships that we have is to reach out to our first responders and educate them on A, the materials in the pipeline, and B, how they can, if they ever needed to, respond to them. And it doesn't have to be a fire per se. It's just about safeguarding the public, right? If there is some release of any material, it's the opportunity for them to have the knowledge and the equipment to respond in a safe way and to keep the public safe. So that's a big part of this, right, is making sure our employees are capable and trained responders, as well as our first responders today. Again, they do great work, but oftentimes, again, they just don't have the ability to exercise that muscle when it comes to pipelines. And so that's an important part, is the training. So training without practical application is not nearly as good. And I think all of us can understand that and appreciate that. So then we have planned exercises. Some of those exercises are driven through those regulations. So depending upon the size of the pipeline company, depending upon the complexity of the operation, they may have different level, a different number of drills that they have to complete. One of those drills, though, needs to incorporate the deployment of response equipment. So if you're on water, a typical response piece of equipment is a boom. You probably need a boat to deploy the boom. The boom is nothing more than a device that floats. It's strung from one piece or one location in the water to another location. Say if it's a small creek, it might extend the entire width of the creek. If it's a larger body of water, it might be there to just make a circle around, say, if there was some hydrocarbon on that water. And the idea there is that it contains it and collects it. So we might exercise that. Another thing that we might do is, say if it's if there's an issue on ground, we'll drill with all the regulators, and in this case, if it's on the land, it'll be the US EPA along with other state and local agencies. If it's on water, it will be the US Coast Guard and other state and local agencies. And so we'll partner with them in these drills. We'll help work together on a scenario that seems realistic, and we'll work through with them on the resources that they can bring, the resources that we can bring, and together we understand, hey, if this happened, how would we tackle this problem collectively? How would we do it, most importantly, safely? And so those things are all planned out ahead of time, and at our company, at Marathon Pipeline, we do many, many drills a year. Every 3 years, we have to do a very specific type of drill, and that's called a worst case discharge scenario. And that drill really centers on, if we have to model all of these different types of spill events, and we have to identify the one that is the worst for that given geographic area. And again, we will partner with all of those appropriate agencies, Coast Guard or the EPA, local agencies, and state agencies, and those all depend on the state that you're in. They take a little different form or shape than what you might see from one state to the next, or one local municipality to the next. And at that time, again, they'll all be involved in the drill development, and we put together a realistic scenario, and then we drill on that. We talk about, what if this happened? What if this changed? Different injects come into play. And these are critical, A, to establish relationships so they know who to call, we know who to call if something happened, and that we have some trust that we are trained, they are trained, and we're all talking the same language. And that's an important part here, and I'll touch on that here at the end. And then lastly is there's other stakeholders other than just those government agencies. And having those stakeholders be a part of the drill planning is important as well. And so you'll see here we have tribal, so our tribal nations are critically important that they understand, and we understand how we need to interact with them. And they have very specific requirements, as they should. And again, but we need to know those ahead of time. We can't walk into something and they see us for the first time. That's not an appropriate way to engage with our stakeholders on the right-of-way. And then OSRO here is basically, those are our spill response operatives or contractors. And so those are specialty contractors that pipeline operators will call, that have specialty equipment that's able to collect and control pipeline releases. And so it's an important part that they are also part of the response drill and the planning activities that go into the drill. So one of the things that happened many years ago, and this originally started with wildfires out west, and there were a handful of serious events where several of our wildfire firefighters were caught pinned in by the wildfire. And they walked into harm's way and didn't understand how to get out. And they had poor communications at the time. And as a result of that, there was a lot of changes that occurred. And one of them is the incident command system that was bred out of these wildfire incidents. And the incident command system developed a command and control style framework upon which all abnormal events can be responded to. It's scalable, and it uses consistent terminology no matter what industry you're in. You could have a firefighter that knows incident command system. You could have something happening on water that's not pipeline related at all, and the U.S. Coast Guard is going to be very familiar with the incident command system. You could have the U.S. EPA, and they're going to be very familiar with the incident command system. You could have your local emergency management agency, and they're going to be very familiar with the incident command system. We will all speak using the same common terminology. And with that, it brings together a leadership framework that's critically important to the success of an emergency response. And that framework involves the responsible party. So usually it's the entity that owns the asset that's involved. That usually involves a federal on-scene coordinator, and in pipelines, most often, that's either going to be the U.S. Coast Guard or the U.S. EPA. At the state level, it will involve, again, depending upon where the asset is and how the state's developed, there's usually some level of emergency management agency that gets involved at the state level. And they will talk for the different state agencies and be the liaison back through those agencies. And then at the local level, again, there's local EMAs that get engaged. It may, for a smaller municipality, just be the fire department. And there's nothing wrong with that, but they are well versed in this terminology. And so how we develop and respond to the incident is different for each incident, but the framework that we use is the same. And that's really important to understand, that we're all talking with the same knowledge and the same framework and the same terminology. And again, we can take questions on that later on if folks have that. But that's key part in the training, is that everybody has this similar training, that we're aligned on how to respond to these events using that framework. That is probably the single biggest advent in advancing emergency preparedness in the last, I'll say, 40 years. Okay, so this is just a little bit, we're going to switch now back into pipeline operations. I want to talk a little bit more about how pipelines are controlled.
Pipeline operators are constantly watching over their pipelines to make sure everything is running safely. Pipeline operators use control centers with personnel watching 24/7. Conduct regular overflights and drives along the pipeline route, and use advanced detection technology and analytics to monitor the pipeline. Pipeline safety starts with a comprehensive program to prevent anything from happening in the first place. Pipelines are constructed with high-grade steel and coated to prevent corrosion. Proactive inspections look for issues before they become problems. Preventive maintenance keeps the pipeline operating safely. Pipeline operators monitor their pipelines 24 hours a day, 7 days a week, 365 days a year. Specially trained controllers keep a watchful eye over pipeline pressure, flow, and volume. Pipeline operators can quickly shut down a pipeline if monitoring technology indicates a potential leak. From their central control centers, pipeline operators will remotely stop pumps and close isolation valves. Pipeline control personnel are trained to shut down their systems, diagnose whether an alarm is showing a leak, and not restart until personnel confirm the pipeline is operating safely. Pipeline operators regularly patrol their pipelines, looking for any signs of problems. Planes or helicopters fly above the pipeline, scanning the pipeline route. Pipeline personnel drive or walk along the pipeline, checking from ground level. Unmanned drones, special cameras, and even satellites can all help pipeline operators make sure everything is operating safely. Pipelines are equipped with sensors and gauges along their route. Sensors can detect a drop in pressure, potentially indicating a leak. Flow gauges monitor product passing through the pipeline, ensuring everything remains inside the pipe. Pipeline sensors and gauges feed their data into central control rooms, where operator personnel constantly monitor the pipeline on computer displays. Pipeline operators use computers with advanced analytics to detect potential leaks on their system. Computer algorithms account for changes in temperature, terrain, or distance from a pump station, all variables affecting product volume and potentially indicating a leak. Pipeline operators are also researching new machine learning techniques to harness AI and separate real from false alarms. Pipeline operators are developing and deploying advanced technologies that can smell trace amounts of hydrocarbons in the soil, see their chemical signature in the air, or hear tiny acoustic vibrations produced by a hole in the pipe. Smart balls traveling inside the pipe listen for acoustic vibrations. Pipeline operators test cable systems installed alongside pipes to detect trace amounts of hydrocarbons. And special cameras mounted to airplanes or helicopters detect hydrocarbon vapors. All of these technologies can help the pipeline operator know that the pipeline is operating safely.
All right. Well, again, that was just to kind of give you a little bit of background on pipeline operations from the remote control perspective. So what many people don't realize is that the pipelines are typically start and stopped from a remote location, not where the actual assets are located. They can be anywhere in the country, these control centers, and they will remotely operate these assets. And so this is a picture in the backdrop here of actually one of our control rooms at Marathon Pipeline. And that's staffed 24/7, and there are trained, I'll say heavily trained individuals that are monitoring and taking action on the pipeline at all times. And so we talked about remote product movement, so they're controlling and starting and stopping the assets. The next one here I'll draw your attention to, it says SCADA alarms or SCADA technology. And so SCADA stands for Supervisory Control and Data Acquisition. You don't need to know much more than it's our computer systems that operates the pipeline. That's the ability for us to get telemetry and remote sensing devices, all that information, and then combining it into an interface that the controller or the pipeline operator can use. And that's really I'll say the common terminology within the industry. So you may hear from time to time, if you talk about control technologies for pipelines, SCADA is the general terminology that's used to describe that computer system. So there's, as you saw here, there's various alarms that alert the controller to things happening. It just might mean, remember I said we have all those different products in the pipeline? It might just say, hey, controller or pipeline operator, you now will see kerosene in the pipeline and not gasoline. It just might alert them to there's now gasoline coming into the pipeline and not kerosene. It can be something simple like that. It's expected. We want that to happen. But it can also tell us there's an unexpected maybe change in flow, an unexpected change in pressure. And as the video articulated, there are systems that are calculating what we see and what we would have expected to see. And if those systems are out of, let's say an alignment, then we get an alarm. And the individuals have a very short amount of time to understand what the alarm is saying and then take action. So at our company alone, we have different ways that we can initiate this alarm. Some comes from that remote technology. Others come from the stakeholders like you. In fact, most of them do. And we shut down our systems about 400 times a year. Just because someone calls in and said, hey, I smell something, or I heard something, and we will send an employee out to dispatch it. We shut down the line safely, and I'll say in almost every instance, it is something else. That perhaps they had some paint thinner in their house, and the can had a little leak in it, and that was the odor they were smelling. But it could be signs of something else. And that's why it's imperative that all of the stakeholders along the right-of-way feel empowered to contact the pipeline operators that are in their area. They need to do that because we can't take on the off chance that something is wrong and we don't go and investigate. It's really, really important that we do that. And the last thing I'll mention, and I touched on it briefly, is the employee training. So controllers, those are the pipeline operators, it takes many, many months of intense, this is everyday training that they're working to be able to operate a pipeline on their own. And then even with that, they're never really on their own. There's always support networks to help that. There's engineering supports. There's other people that they can contact that are on their shift usually and say, hey, I have a question about this. This seems abnormal. And so those are important things. Critical with all this, and most, I believe, operators have this sentiment, is that if you don't see something that you like, you are obligated to take action and move towards safety. Most often, that means the pipeline gets shut down. That's what we're telling these pipeline operators, is that if you see something that isn't what is expected, you are obligated to shut down. And the law kind of dovetails into that our controllers, our pipeline operators, have that obligation to shut down the pipeline to, most importantly, to safeguard public safety. So one of the other things that's been in the news since 2020 is cybersecurity. And I mentioned to you earlier that the TSA is the governing agency that oversees cybersecurity for pipelines. And so there's an element, though, that PHMSA also gets involved in, and that is the safety aspect. There's the cyber actual event or cybersecurity defensive measures or countermeasures, but then there's the safety aspect. So PHMSA and the TSA will partner together to help ensure that we have the right cybersecurity measures in place. So some of the big hallmarks around cybersecurity, well, some might be pretty evident to you, some may not be. I'll touch on a couple of them, nothing in detail, because we don't share those details with anyone. But no internet connectivity, meaning the system, that SCADA system that controls, that software that controls the pipeline, we never want that connected to the internet. Why? Because that's a portal into the system that someone nefarious, some bad actor could use to try and get in and take over. So we always want to make sure that we have segregation of our networks from the internet. The other thing that we want to make sure is that even within the company's network, we want to have firewalls. So maybe you've heard of that term before, but that is simply, those are devices that are in place that stop traffic from going from one location to the next. And so that's really important. And then the other thing is monitoring that traffic. Do you have the right software that monitors the traffic that says, that's the only person, that's the only things we want going back and forth? And that's really important as well. And so that's an advancement here, I'll say in the last 8 years, that's been very helpful for us, is the ability to monitor this network traffic to a much higher degree than we've had in the past. And so those are some of the steps that we're taking on the cybersecurity front. And I think this is an area that we always have to have constant vigilance on. We talk about pipeline safety. This is an area that, there are nefarious actors out there, nation states, that they look at critical infrastructure like pipelines, and we need to make sure that we're on top of our game. Okay, the next thing I want to touch on is some technology to help improve pipeline performance. So one of the things that we're seeing here, this is a picture of a plane, right? And one of the changes that we're looking to aerial patrol. We're required to patrol our pipelines either through the air, we look at them, or through the ground, meaning someone will walk them. Some places are harder to walk than others, right? Or more remote. And other places, it's better to fly. But when we think about flight, it hasn't changed since the Wright brothers. Someone's looking out of the plane and they're trying to observe if something's happening on the pipeline right away. And one of the things that we see is that we're not as effective as we would like to be. The human eye isn't as good as we would like it to be. But now, with the advent of machine learning and artificial intelligence, we're able to show a camera what an excavator on the right-of-way looks like. And that camera can, as it's flying along, can say, oh my gosh, I just detected an excavator. And it can send out an immediate alert that we can dispatch someone to go and see what's happening. Third-party damage is still a critical issue for pipeline safety. And our ability to detect these threats is becoming more and more advanced. And this is something that we think can help elevate the entire industry moving forward. We're still developing the technology as an industry, but it's coming along. And again, we're changing something that hadn't changed since the advent of flight, and we're getting better at it. And I think this is a great way to help improve pipeline safety. The other things that we can use this technology for is the ability to detect the onset of a geohazard. Geohazards continue to be an opportunity to improve in pipeline safety. And if you've seen some of the issues that have occurred over the last 7 years or so as it relates to geohazards and pipelines, we're able now to detect very slight land movement through the use of different types of imaging. LIDAR is one, it's laser imaging and ranging. And just using simple cameras and the ability to detect how quickly the land is moving. Those early shifts allow us as pipeline operators to go in, get geotechnical experts out there, assess the situation, and then quickly develop a remediation plan. That's really important for us moving forward. Getting that data almost real time, gosh, there's nothing much better than that. So other integrity programs that pipeline operators have. If we think about pipeline assets, they're kind of broken down into three main areas. One is tanks, the other is the pipeline itself that's on the right-of-way, and the other one is facilities. Oftentimes the tanks and the facilities are linked, but we separate them only because one is a large storage vessel and the other one has piping, but they're all inside a given area. So just a little bit of background, I'm going to focus mainly on that mainline pipe because that's where we see any incidents that occur have a higher likelihood of impacting people or the environment. And so you can just see here on an annual basis, there's about 104,000 miles inspected each year. And so we talked about, well, how many miles of pipe out there are there? And now you start to see that there's quite a bit. And so in the liquid space, these are the number of repairs that are made. And the these are the total number of excavations based on the inspection data. So the excavation would be where we inspected the pipeline based on that data. And so just a little bit of details there. So what can we do as it relates to preventing pipeline issues? One of the biggest issues that we see still as a relation to events is corrosion. And there's three ways I want to talk on how to prevent corrosion. There's external corrosion, meaning corrosion that comes from, when I say corrosion, think of rust, right? It's corrosion that comes from the outside in, and there's corrosion that comes from the inside out. So the inside of the pipeline to the outside. And big things here that we see as it relates to this is coatings. Coatings are nothing more than paint. So think of painting on your pipeline. When you put paint on your wood siding, as an example, that's a protectant, right? It protects it from different types of forces that would degrade the wood. And these coatings are no different, right? They help protect it from different types of soils, different types of water, different types of activities that could create corrosion. Now, over time, maybe that coating got scratched, maybe maybe an excavator dug and nicked it or something like that. Maybe a rock scratched it. And that means that that pipe is bare. And so we use two other mechanisms, or another main mechanism is what we call cathodic protection. And by that, we put a very small voltage, electric current, onto the pipeline, and that helps shield the pipeline from corrosion occurring. And it works on the same principle as a battery. I'm happy to explain that to someone later on. But the essence here is that small electric current is what enables us to help keep the pipeline safe from external corrosion. The last thing that we do for internal corrosion is that we want to make sure if there was ever any water or anything, any other contaminants that was in the material we were shipping, that doesn't sit at low spots in the pipeline. If you have drains in your house, think about water collecting in those low points on your drain, right? Well, this is no different. We want to make sure we push all of that water out of there so that we don't have the opportunity for corrosion to begin inside of our pipe. And so we use what we call a PIG, which is a device that we put in the pipeline, and it's propelled by product flow, and that PIG then is what sweeps out all of that water. But don't worry, we capture all that. We don't let it go into the product. We know when it comes in, and we capture all of that material at a station, and we remove it from the material that we're transporting. So a couple other things here, and I know I'm running out of time, so I'll be moving quicker here at the end here. So continue to invest in new technologies to inspect our pipelines. That's key, right? And I mentioned transitioning away from hydro testing and getting into inline inspection. Again, those are tools that we put in the pipeline and that they inspect for metal loss or corrosion. They inspect for dents. They inspect for cracks. They inspect for manufacturing defects, or they might inspect for third-party damage. You can also inspect for the signs of a geohazard working on the pipeline. All of these technologies have been advanced significantly within the last decade. That gives us a greater clarity of what's happening within our pipeline. And so the next piece of that is the repair, right? So you saw that we were digging thousands and thousands of time, making thousands and thousands of repairs. Those repair typically could mean like, hey, we saw it and that coating was damaged, and we don't want it to be a place where corrosion can accumulate. So we put new coating on. We clean up the pipe and we put new coating on so that corrosion can't accumulate there. Perhaps the damage is to the point where we say we need to add more steel to the pipeline. So we do so. And that's called a sleeve. The sleeve is nothing more than a containing vessel that we weld onto the pipeline that can hold pressure. And again, it's just adding more steel to the pipeline to increase its strength. Or we can just say, hey, we're going to replace that entire section of pipeline. We cut it out and put a new one in. So the last thing I want to touch on, and this is critically important for us moving forward, and I know I'm right on my time here, so I appreciate it, is stakeholder engagement. And this is an opportunity that, I touched on. We're not where we want to be on the safety side. we're not where we want to be on the stakeholder side either. One of the opportunities for us to make a step forward into this is, I'll say, moving beyond just regular compliance engagement from true engagement with all of the parties that need represented. And the way we're doing that is through a new recommended practice from API, and it's bannered under API 1185. In fact, we were just going to have a stakeholder workshop to help operators kick this off and help train them on how to be more proficient in engaging with the stakeholders. We had some technical problems here, but it was set for November 3rd, so we didn't have the workshop as desired, but we have it rescheduled. We're getting one out here again with these operators to train them on how to better engage with the public. And it's more than the public. It could be tribal nations. It could be agencies. It could be other community developers. It could be regulators. So many different opportunities for us to engage. But it has to be done in a way that uses some core tenets. I just want to highlight those quickly. One is respect. We have to consider each other's positions. That starts with listening and being open to what you have to say. And then taking those points of view and then truly understanding them, asking questions and seeking to learn from their perspective. The other thing that we need is reciprocity. And by that, that's communication and action, but it has to be for mutual benefit. It can't be all one-sided, and that goes for either party, right? And these dialogues, this just isn't for a new pipeline construction. This is for the long haul, if you will, right? This is how we can build a relationship together. And so the next thing I'll mention is inclusiveness. We know that there are different stakeholders, and they're involved for different reasons. And the way they involve is different as well. And we as operators, that's on us to figure out. We need to know that perhaps tribal members want to involve a different way than other community members. And then with that, we want accessibility. We need to be accessible to them and provide mechanisms that works for them. Maybe some people aren't as savvy and they don't want to use email. They just want to call someone, right? They want a phone number to reach out. We have to provide those different options to do that. And the last thing I'll leave you with is equity. We need to know that different stakeholders live under different circumstances and take that into consideration when we develop these plans. But it's important, as I mentioned through all these, I know I'm going through them quickly, but that we engage in this process. But we need to engage it in a way that focuses on listening first. That will be important. So I think we know why it's important. I won't go into this in any other detail, but again, this I'm sure will come up in our Q&A session later on this afternoon. So again, I thank you, and I appreciate everyone's time for letting me go a little bit over. So thank you.